Hello, today we are going to be solving systems of equations, and we're going to be using both substitution and linear combination. Now, some of you may have heard of linear combination as elimination. Same thing. So what I'm going to start with here today is two equations with two variables. Now that's what we're referring to when we're talking about this system of equations. Two equations, two variables. You need to have two equations to be able to solve for two variables. If you just had one, you would not be able to find a solution. You could find a graph, but not a solution. So, substitution, you want to get one of the variables by itself on one side completely so that you can find what it is equivalent to. So in this case, it's equivalent to 6n. So I'm going to take 6n and replace just the m in the other equation. It has to be in the other equation that you know, from the one you manipulated if you had to manipulate one. So now I'm going to substitute this in. So 2 minus 4n equals 16. And we're going to substitute the 6n in replace of m. So now I'm going to just do some simplification. 12n minus 4n equals 16. 12 minus 4 is 8n equals 16. And then I can just divide both sides by 8. N is 2. Now that I know what n is, I can bring that back over to here. See how it kind of makes a full circle? And because this went over here. And I can replace the n with 2 and find my answer to m. m is 12. Now, when we want to answer this, we want to answer it in a way that it makes sense, and that would be in a coordinate pair. So my answer to this is 12, 2. Even so I solved for n first, it doesn't go first because in the vast majority of situations where you have two variables and you want to write it in coordinate form like this, you always do it alphabetical. M, then n in this case. There are rare instances where they tell you the first coordinate is something other than alphabetic. So just be aware of that in the future. Here we go. Here's our next example. Now, this one, y is already by itself, so I'm going to go ahead and take this expression and put it in place of y alone. So that gives me 5x plus 3 times whatever y is equals 8. It is a handy idea to put parentheses in place of y and then fill it in, even if it's just a single variable, just so that you keep track of everything and you don't lose little things like negative signs. So now I'm going to go ahead and distribute 5x minus 15x plus 18 equals 8. I'm going to combine like terms, negative 10x, these two, plus 18 equals 8. I'll go ahead and get rid of the 18 by subtracting 18. Negative 10x equals negative 10. And then we'll divide both sides by negative 10. X is 1. Now that I know that x is 1, I can take that back over to here and find y. And y is 11. So my final answer here is 111. Again, feel free to pause this video as you need to make sure you can keep up with writing down what is on the board in your notes. Don't forget to take notes. All right, here's our next example. I didn't miss it. All right, good. So now, in this problem, we don't have a variable isolated on one side of the equal sign. So because of that, we need to get one by itself. Now, some people would use one of these. Why? Why not use one which it's much simpler to get by itself? I always suggest students start with the one where a variable has either a 1 or a -1 coefficient and get that variable by itself. Otherwise, you're giving yourself a lot more grief than you need to. And in this one, if you got x by itself, you'd have fractions all over the place. Here, if you got y by itself, you'd still have a fraction you'd have to deal with. Much easier to get this one with the variable by itself. So I would move x over and then divide by a -1. You could just as easily move y over and bring 4 on this side. I'm going to subtract 3x from both sides. So that gives me, let's see, -y equals -3x plus 4. And then I'm going to divide everything on both sides by a -1. Or multiply by a -1. That gives me y equals 3x minus 4. This is what I'm going to substitute in for y over here. So 5x plus 3 times y equals 9. I'm going to fill that in with 3x minus 4. And then I'm going to solve it. Let's see, combine like terms, 14x minus 12. Add 12. Let's see, 9 and 12 is 21. All right. This is interesting. Divide by 14. Hopefully I didn't make a mistake. X equals, now if I reduce this, 7 goes into 3 and 2. All right. So there's my first answer. I bring that back up here. Ooh, that's funky. 3. Let's try that again. And y equals 9 over 2 is 4 1/2. So that gives me 1/2. So my answer for this problem is 3/2, 1/2. Now you may say, wow, that's not a very nice answer. It's really not that bad of an answer. But it certainly is an answer that you have to take a look at and go, oh, did I make a mistake? And just double check your work, because most of the time our answers are going to be nice and neat, but once in a while we get ones like this where it's not so nice and neat. So I double check my work. Let's see. 3 minus 4, that's all good. I plugged it in. I distributed correctly. I combined like terms correctly. And yeah, no, that's right. So 3/2, 1/2. All right, let's take a look at our next example. All right, before we can get to our next example, this is our next type of solving of systems of equations. And this is linear combination, or some call it elimination. And I've got some steps here for you to write down. First, you want to get all your equations in the form something x, like a number x, plus a number y, or minus a number y, equals a number. So the x term, the y term, the equal sign, and then the number. That's how you want them written. If they're not that way, rewrite them. If they're both exactly the same form, you don't have to rewrite them like this, but in general, it's easiest if they're like this. All right, number 2, if necessary, multiply one or both lines of the equations by numbers, so one of the variables will cancel out when you add them together. You'll see what I mean in a minute. Step 3 is solve for the remaining variable, the one that's left, and then step 4, substitute in to solve for the other variable. Hopefully you've gotten this written all down, and we'll move on. Here we go. So when I look at this, I can see right away that negative y and positive y, when we add them together, would cancel out. So I don't have to multiply this one by anything. I can just add straight down this plus this. 1x plus 2x is 3x. Negative 1y and positive 1y cancel out when I add them, and 7 and 5 make 12. Now I can just solve. This is step 3, solve for the variable that's remaining. And once I know that x is 4, I can go back up to either equation. In this case, I'll probably do the first equation. And 4, instead of x, minus y equals 7. I'm going to subtract 4. Negative y equals 3. So that means y, positive y, equals negative 3. Or multiply or divide both sides by a negative 1. So my final answer here, x is 4, y is negative 3. To check any of these problems to make sure you've done it correctly, just take the coordinates x and y and plug it in to each one to be certain that it is correct. 4 minus negative 3, that's plus positive 3, is 7. 4 times 2, 8. Minus 3 would be 5. Here's our next example. Now, in this one, you can eliminate either variable, but the easiest one to eliminate is the one where it has a 1 or a negative 1 coefficient, because I can just multiply this entire equation by the same denominator, but opposite sign, because remember, you want it to cancel. So if I multiply everything on both sides here by negative 2, it's going to eliminate that x variable. Now I'm going to rewrite this down below. Negative 2x. Now negative 2 times negative 3 is positive 6y equals, don't forget to multiply the other side. A lot of people forget that. Negative 4. Now this equation is now down here, and I'm going to combine them. Now if you prefer to rewrite the entire thing, which we'll do in our next example, then that's fine as well. 2x plus, we're going to add straight down, negative 2x, that cancels out. 5y and 6y is 11y, and 15 and negative 4 is 11. So all I have to do is divide by 11, and y is 1. Now that I know what y is, go back up and pick either equation, plug it in, and solve for the other variable. 2x plus 5 times 1 equals 15. Obviously, I plugged it into this one. 2x plus 5 equals 15. Subtract 5. 2x equals 10. Divide by 2. X is 5. So my final answer here, x is 5, y is 1, and that is my solution. Again, you can plug 5 and 1 back in and check to make sure that the equation comes out the same. All right, let's go to the next example. Is that our last? Nope, one more after that. Okay. In this one, it does not matter which variable we try to eliminate, because we have to multiply both equations by something to be able to eliminate one of the variables. Now, I'm going to choose x in this particular case. It does not matter which one, but I'm going to pick x. The way I would suggest that you do it is you take the variable's coefficients that you're trying to eliminate, and you put this one up here and this one down here. The only thing is you have to make sure one of them is negative if they're both the same sign. If one of them's negative here and this is positive, then you just bring the number without the sign, because now you have a negative and a positive and it'll work out. So I have to pick one. I think I'm going to make that one the negative one. So that means I have to multiply the top here by -3 and the bottom here by +4. Now you may say, well, I'm multiplying by two different numbers. Well, that's okay, because this entire equation, both sides are by 4. This entire equation, both sides are by -3. So it's still an equation. They're still equivalent expressions because you've multiplied by the same number on both sides for that one equation. So now what I'm going to do here is I'm just going to transfer this to the side so that I can see it easier to work with. So -12x, -15y equals +18. So I distributed the -3 to each. -3 times 4x, -3 times 5y, and -3 times -6. Down here I'm multiplying by 4. 4 times 3 is 12x. See how they both come out to the same except for the sign. Plus 8y equals, let's see, 108. Because 4 times 20 is 80, 4 times 7 is 28, add them up, 108. So now I'm going to add these together. This cancels. This becomes -7y, and this, let's see, 8 and 8 is 16, carry the 1, 2, 1, 126. So the next thing I'm going to do here is I'm going to divide both sides by that 120, by -7. So I can solve. And it's not a problem to pull out a calculator and make it go a little faster. So when I divide both sides by -7, y equals -18. Kind of a big number. Let's go back over here and pick one of these, substitute in 3x plus 2 times